now we're going to look at the electron dot diagrams, also known as Lewis dot diagrams. So this comes after Bohr-Rutherford. So as long as you understand the Bohr-Rutherford and how the electrons are placed, then you should be okay for going forward with the Lewis dot diagrams. So if it helps, I would suggest when I drawing them out. So when I give you one, I'm just looking through the textbook to see what there is anything on the Lewis dot. If so, you no. So this is just jumps right into new stuff. Okay, so I was just checking to see if there was anything. If you wanted to look back over anything, you could, but there's really not. Okay, so I'll just go to the periodic table. So we're going to start. So we're going to do Lewis dot diagrams. Okay? So a term that you would have learned with this last year is valence electrons. Okay? Now, valence electrons are the electrons that are on the outermost shell. So I'm going to just pick an example here. So if I had asked you to do, let's do carbon. Okay, so we're going to look at carbon. So we're going to go over it all again. So carbon, atomic number, whoopsies, I always skip letters when I'm writing. Atomic number is 6. Okay, so that means protons is 6, electrons is 6. Mass is 12, so then we take away the atomic number, which is 6. So that's 6 left over, which means there's 6 neutrons. Okay, that's everything that you guys need to know right now. Hopefully you're able to find the atomic number, protons, electrons, and neutrons. Okay, great. That's the base. You need to know this. If you don't know this, you will be completely lost going forward. So now let's start with the Bohr-Rutherford. Okay, you just went over Bohr-Rutherford. Bohr-Rutherford. Okay. So let's do that. So protons, I will do the longhand right now, but then I'm going to do the shorthand. So protons is 6, neutrons is 6. This is why I picked one that had low electrons. 2 in the first shell, and then we have 4 in the second shell. All right. So you should be able to do this up until now. Okay? Now we're dealing with, when we do the Lewis dot diagrams, we are dealing with just the valence electrons, okay? The valence electrons are the electrons in the outermost shell, okay? So I'll do this over here. Valence electrons, okay? Electrons in the last shell. Okay. So just quickly, I don't want to go too off topic here, but say we were dealing with helium. Okay. Helium has protons 2, neutrons 2. It would have 2 in the first shell. Okay, that's helium. It has 2 valence electrons. Even though it has just one shell, it still has 2 valence electrons because it's whatever's in the last shell. Okay? So the Lewis dot diagram was designed so that you could, by simply having that symbol there, you could show someone how many electrons are in the last shell. And that obviously becomes important because we're going to look at when the elements go from being an atom to an ion, which means they're giving away electrons or they're taking on new electrons, and it's all based on the electrons in the last shell. Okay? So we're looking at carbon right now. So the Lewis dot diagram for carbon is just doing dots that represent the valence electrons. So how many valence electrons does carbon have? Valence electrons. Okay? Carbon has 4. There's 4. So how do we do that with an electron dot diagram? You just do the symbol. Okay, and this is why I was doing my Bohr-Rutherfords in like sets of 2, kind of in a square, right? On the top side, bottom side. Same thing with the electron dot diagram. Electrons. has 4. 1, 2, 3, 4. That is our dot diagram for carbon. That's it. That's all we're doing. We're doing these little dots around the symbol to represent the valence electrons. So helium, that's the symbol for helium. You could do it this way, or some people do it this way. Okay? So it's just the dots on the outside. I'm going to do one more, and then I'm going to ask you to do 2 practice ones, because I do want to show you what it looks like when it's full. So let's do neon. Okay? Neon. I'm just going to quickly go through the Bohr-Rutherford. I'm going to do the shorthand one, actually. So neon has 10 protons. It has 10 neutrons. So it has 2 in the first shell, 8 in the second shell. Okay? So electron dot diagram for neon, I'm just going to put it over here. Neon, it's just going to be like so. I do it kind of in a box, right? Bam, bam, bam. Okay, that's the electron dot diagram for neon. Okay, so now I'm going to ask you to do 2. I'm going to ask you to do, I'm just going to pull up here. I'm going to ask you to do fluorine. Okay, and I'm going to ask you to do sodium. Oh, I was just about to do the symbol. Sodium. Okay, so pause here, do fluorine and sodium. Okay, go. Okay, so let's take it up. Fluorine, okay, symbol is F. Okay, I'm not going to go through the whole Bohr-Rutherford diagram of it, but if it helps, instead of being able to do it in your head, how many are in the last shell, do a Bohr-Rutherford, okay? Do whatever you need to do to figure it out and get the proper answer. So fluorine has 9 protons and electrons, 2 in the first shell. So that means in the second shell, it would have 7. Okay, so 7 valence electrons. 5, 6, 7. Done. All right, that's it. Sodium. Sodium has 11 electrons, okay? So it would have 2 in the first shell. It would have 8 in the second shell. It would have 1 in the last shell. That is 1 valence electron, sodium. Or sodium. Done. Okay? That's it. That's all you have to do. It's just the valence electrons, which is in the last shell, and you're putting them in a nice little structure around the symbol. And the symbol is the letter that represents this certain element. Okay? That's it. That's all.